Hello, Algebra 2A. We are going to take a look today at lesson 58, where we move on to another method of solving quadratics. And our objective for today is to use completing the square to solve a quadratic equation in the form ax squared plus bx plus c equals 0. Trinomial ax squared plus bx plus c. C is the blank term. C is going to be called our constant term. So constant starts with a C. C in the problem. There is our constant term. Next, factor the expression x squared plus 2x plus 1. So in a basic trinomial, when your a term is 1, you're trying to multiply to the constant term and add to your b term in the middle too. Well, the only way to do that is to multiply 1 times 1. That's also going to add up to 2. So we get x plus 1, x plus 1. Now, this is a special type of trinomial that factors into two exact same binomials. It's called a perfect square trinomial. So perfect square is going to have a number that square roots into the exact same two values, and a perfect square trinomial will also break down into two binomials that are exactly the same. X plus 1 times x plus 1 can also be x plus 1 squared. And lastly, true or false, if a number x is a perfect square, then the square root is a whole number. So if x is a perfect square, like 25, and you square root 25, yes, you will get a whole number 5. So true or false, that one is true. Property says that if you have a variable squared equal to a number a, then in general that your x is going to equal plus or minus the square root of a. So just really quickly, if you have x squared is equal to 25, which we just looked at, to solve for x squared, you're going to square root. So x is going to equal 5, which is the square root of 25. But there is also another value that when you square it, it would have equaled 25. That is negative 5. So whenever we square root a value, we have to account for the positive and negative of the solution. Perfect square trinomials. So looking at example 1, solve x squared plus 6x plus 9 is equal to 64. Now this trinomial is a basic trinomial, but it is very special because the numbers that multiply to 9 and add to 6 are both the same, 3 and 3. So that means that we're dealing with x plus 3, which x plus 3 can be rewritten as x plus 3 squared. And that's going to be set equal to 64. After that, to start to get into this x, we have to get rid of this squared, which we are going to square root. So we square root the left side, square root the right side. We're going to get x plus 3 is equal to the square root of 64, which is 8. But using our rule from above up here, whenever we square root a value and we get 8, it could be a positive or negative 8, two solutions. Now from there, we're going to use algebra to get our x alone. We're going to subtract 3 and subtract 3. So ultimately, x is going to equal negative 3 plus or minus 8, which is going to give us two solutions. Negative 3 plus 8 is going to be 5. Negative 3 minus 8 is going to be negative 11. So there would be our two solutions for that problem. That your c term, your constant, is going to be a perfect square. So 49, you look at 49, perfect. It's the square root of it is 7. So to multiply to 49, we're going to be using 7 and 7. But we need to add to negative 14. Well, 7 plus 7 is positive 14, so we're going to use a minus 7. minus 7. So that's going to mean, like above, we factored into x plus 3, x plus 3. This is going to factor into x minus 7, x minus 7. And we can rewrite that then as perfect square trinomials are two of the exact same factors, x minus 7 squared. That's going to equal to 10. Now to get into my parentheses there, I have to square root. So I will square root, and we're going to be left with x minus 7 is going to equal the square root of 10. Now, square root of 10 is not a perfect square like 64 was above, so we'll just leave it in radical form. And we would simplify its radical form if we could. This one we cannot, so this one is just going to be plus or minus the square root of 10. And to get x alone, ultimately, we would add 7 to both sides to get x alone. So x is going to equal 7 plus or minus the square root of 10. And like above, where we had integers and we could add together and find out solutions are 5 and 11, this is in radical form, so we cannot combine 7 and any irrational number like the root of 10. So that is our simplified answer. Set up to be perfect square trinomials. Well, that's not always going to be the case. So sometimes we will have to make our own perfect square trinomial so that it can factor, because we found out that not everything can factor perfectly. So completing the square. So how to make your own perfect square trinomial. Given a quadratic in the form x squared plus bx, add it to the square of the half of the coefficient of x, which is the b. So we take b divided by 2 squared to create a perfect square trinomial. And here we have an example of a perfect square trinomial on the left side. And then it factors into x plus b over 2 squared. So let's take a look at an example of one, and we'll complete the square to make it a perfect square trinomial. So if I had something like this, x squared plus 10x plus something, how could I make this into a perfect square trinomial? Well, what this is saying is take the b term. So recall from our warm-up, there's our b term, and cut it in half and square it. 10 divided by 2 and squared is going to equal 25. So there is your constant term, your last term of your trinomial that will make this a perfect square trinomial. So you can take your b term divided by 2 and square it to always make a perfect square trinomial. Now continuing, you can also factor this. That's what we're trying to do. We want to get it so it can factor. And it's going to factor into x plus b over 2 squared, which our b over 2, 10 over 2 was 5. So x plus 5 squared is going to be how that factors. And that makes sense because 5 times 5 is 25, which is this term. And 5 plus 5 is 10. Let's take a look at one additional. Let's say I had this, x squared minus 10x plus something needs to equal something that I can factor. So again, we'll take our b term, which is negative 10, divide that by 2 squared. Well, negative 10 divided by 2 is negative 5. Negative 5 squared is still going to be 25. So you'll find that that c term is always going to be positive, because whenever you square a negative number, it still ends up being positive. But now when we factor it, we need to add to that negative 10 in the middle as your b term. So it's going to be x minus 5 squared. And we can factor using our old methods of factoring, but it's always going to be that b term cut in half, as that is what we found when we get that negative 5. Negative 10 divided by 2 gives us this negative 5 right here. Make our own perfect square trinomial to solve. So here are some steps to follow, and we'll refer to these steps as we go. So First thing that we look at is x squared minus 10x plus 19. This would ask, if I was going to try to factor this, I'm trying to multiply to 19 and then add to negative 10. Now 19, there's only one way to multiply to it, 1 and 19, and there's no way that I can add to negative 10. So this you cannot factor, but you can start to make your own trinomial that factors by making a perfect square trinomial. Next, step 2, we would look at if a is not 1, then we would divide out a factor to make it so a is 1 so we can complete the square. Number 3, we will add our b term divided by 2 squared to both sides, which in that last problem was that 10 divided by 2, square it, and then add 25 to both sides. Number 4, we'll factor, square root, and then solve the two equations to find our two solutions. And quadratics always have two solutions. So x squared minus 10x plus 19. Step 1, we want to arrange the equations so that we have just the a and the b term on one side. So we're going to subtract 19 over. So we can use algebra to do that. Subtract 19, subtract 19. Heading down then, we'll have x squared minus 10x. Now I like to just put, we are going to complete the square with something right here. So we'll put that. We are going to do that here in a second. And then on this side, we're around negative 19. And anytime we are doing algebra with operations on both sides, we need to balance our equation. So we're going to add something to that side as well. Here's where we complete the square. So negative 10 is my b term. I'm going to take negative 10 divided by 2 and square it. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. Change colors just to make it stick out a little bit more. We're going to add 25 to this side and then add 25 to this side. So we skip step 2 from above because the a term is 1 already. We'll see one that is not 1 on the last problem. Next, we will factor the perfect square trinomial, which is going to be negative 10 divided by 2 is 5. So it's going to be x minus 5 squared. And by negative 10 divided by 2, I did mean to say negative 5. And that's going to equal 6 on my right side. And now we're just down to solving for x. So we'll square root both sides. X minus 5 is going to equal plus or minus the square root of 6. So that square root of 6, I would look to see if I can simplify that at all. I can't, so I just leave it as plus or minus the square root of 6. And lastly, we'll add 5 to both sides. Add 5, and 5 and square root of 6 are not going to be able to combine, so we're just left with our answer is 5 plus or minus the root of 6. Complete the square to change something into vertex form. Before I write this problem, I'm just going to remind you all what vertex form is. Vertex form is a way to write an equation that will show the equation's vertex, its highest or lowest point. So vertex form is y equals a times x minus h squared plus k, where your vertex, which I'm going to call v, is going to equal your h coordinate represents the x of that vertex, and k represents the y of that vertex. So we're going to get this into vertex form. So right now you'll notice it's in standard form. As we read through this, we want to get it into that vertex form. So a diver is competing for an Olympic medal. His height in feet above the water can be modeled by the function f of x equals negative 3x squared plus 6x plus 24, where x is the time in seconds after he begins the dive. Write the function in vertex form by completing the square, then find the maximum height and the time it takes to reach that height. So as we look at this problem right now, f of x, I am going to rewrite as y. That's just your output variable. It can be rewritten as y. So y is equal to negative 3x squared plus 6x plus 24. So as it stands right now, we have a -3 in front of our x squared, which means our a term is now greater than 1. And then we also have this 24 that we will work with. So our first step from above was, let's get this constant term moved over. So we're going to have y minus 24 equals -3x squared plus 6x. Then step 2 said that we don't have a term of 1. We're going to divide out by -3. So everything gets divided by -3 to make that a term 1. And now we're going to start seeing things familiar to what we saw in the previous problem. Y doesn't divide by -3, so y over -3. -24 does divide by -3, is 8. And that's going to equal x squared minus 2x. Okay, so that's starting to look more familiar, especially this side is the side that we are going to complete the square right here. I'm going to move this problem to above over to the right here, and then we'll kind of separate it from this because we'll use this at the end. But here's what we got going on. We've got our y over -3 plus 8 plus something, which we're going to complete the square here in a second, is going to equal x squared minus 2x plus something. So that something is what I'm going to complete the square with, and I'm going to use that b term. So just below here, we'll use the b term, divide it by 2, and square it. Lots of 2's happening. -2 divided by 2 is -1. -1 squared is +1. So again, I'll use a different color to highlight. There's our complete the square. Complete the square. Okay, continuing. On our left side, we're going to have y over -3 plus 9, 8 and 1 make 9, is going to equal, now my factoring is x minus 1 squared. Perfect, and we subtract 9 on both sides. Subtract 9 over here, and we're going to have y divided by -3 equals x minus 1 squared is, and then subtracting 9. Now from above, that's looking familiar to our our vertex form, which was what we talked about right away. Lastly, I need to multiply both sides by -3. Multiply by -3 everything, making sure everything's balanced. That's going to leave me with y is equal to -3 x minus 1 squared. And when I multiply -9 by -3, that's +27. So this means our vertex is that h and that k. Our h value is 1. There's my x of my vertex, and my y value is 27. So how high did the diver get? The diver was going to get 27 feet above the ground. Our vertex form that we just found, and looking at the diver's path, the diver took off from a height of 24 feet, dove up to 27 feet. There's the height we were looking for, and then falls down to the water 4 feet away, or 4 seconds after jumping. Then the other equation that was given to us was -3x squared plus 6x plus 24. As you can see, it is the exact same thing. So we just have two different ways to write that diver's progress jumping off the diving board and landing into the water after 4 seconds.